So in this tutorial we will talk about spherical mirrors. So the topic is spherical mirrors. Okay. So as the name suggests, spherical mirrors are obtained by uh, cutting a section of a sphere. So you have a sphere here. This is a sphere, and we cut one of the sections. So we cut like this, and as a result, we get a section. So this is the section that we get. And the mirror, if we polish it, so if we polish the other side, one of the sides, so this is a polish it. So what I will get is a mirror. And since this mirror has been obtained from a sphere through cutting the sphere, I will call it a spherical mirror. So this mirror is a spherical mirror. Okay. So now there can be two kinds of spherical mirrors. So there are two kinds of spherical mirrors. One, two. You can have concave mirror, or you can have convex mirror. So if reflection, so if suppose if you polish the outer surface and the reflection happens from the inner surface, so reflection happens from the inner surface, then it's a concave mirror. But what you do that if you polish the inner surface, so if this is the mirror, and if you polish the inner surface, and in this case if the reflection happens from the outer surface, then what you have is a convex mirror. So till now we have discussed about a spherical mirror. A spherical mirror is something which is obtained by cutting a section of a sphere, and then when you cut the section of a sphere, you can polish either interior or the exterior side, either the exterior side or the interior side. So depending on which side you polish, you will have reflection from the other side. So a convex mirror is something where the reflection happens from the outer side, while for the concave mirror, the reflection happens from the inner side. Okay, so far so good. Now, suppose you have been given a concave mirror. So I have been given concave mirror. So I have been given a concave mirror. This is my concave mirror. Now, given a concave mirror, you know that its outer side is polished. So this mirror must have been obtained from cutting a section of a sphere. So there must be a sphere from which we have got the mirror. The radius, the center of this sphere from which you have got this mirror is called center of curvature. So this point here, this point, I call it as center of curvature. And the radius of this mirror is called radius of curvature. So this radius R is called radius of curvature. So R is radius of curvature. Now, given this spherical mirror, I have center of this section, the section which has been cut. I call this section V, and suppose the center of curvature is C, then this line from C to B is called principal axis. So this axis is called principal axis. So you have a mirror. This mirror has been obtained from a spherical, a bigger sphere. The center of that sphere is called center of curvature. The radius is called the radius of curvature, and this line from center of curvature to the center of this spherical section is called principal axis. Now, when we will talk about in this tutorial or further tutorial, we will do some kind of approximation called paraxial ray approximation. So we will do something called paraxial ray approximation. So according to this approximation, we will talk about only those rays which make a small angle with principal axis. So suppose this is your mirror and this is your principal axis, and I put an object here. I will talk about only those rays which make a small angle theta with principal axis. So basically theta should be a small. And if we work with a small theta, then the approximation that we use is called paraxial ray approximation. So basically what we assume that the theta in our calculations that will be very small. So this is called paraxial ray approximation. Now, given a concave mirror, suppose this is the principal axis, and if you put the object here, what will happen that it will go to the mirror, like the ray will emanate from object and go to the mirror, and it gets reflected. Similarly, it will go to the mirror and it gets reflected. So it's this point. So this is the point where you get your image. Now, if you have this paraxial ray approximation, like if I assume the small theta approximation, then what will happen that my rays will intersect at a point. If I don't have paraxial ray approximation, then the rays don't intersect at a point, or they don't intersect properly, and what I get is blurred image. Blurred image. And this is called a spherical aberration. So let me write it properly. So what I get is called a spherical aberration. So for a small theta, I don't get a spherical aberration, and that's why I will work in the regime where theta is very small, and this approximation will be called paraxial ray approximation. So that's all we discussed in this tutorial. So we talked about a spherical mirror, and we said that we polish the outer surface, then we get what is called concave mirror, and if we polish the inner surface, what we get is a convex mirror. Now, you call a mirror concave or convex depending on which side of the mirror is reflecting. Now, given a concave mirror, we talked about radius of curvature, center of curvature, principal axis, and finally we talked about paraxial ray approximation, where we said that we will be working with a small theta. If we don't work with small theta, then we will get something called blurred image, and this problem is called a spherical aberration.